Okay, good afternoon. Have you studied energetic? Have a good refreshment or rest?
Good lunch.
Maybe you just wash your face.
Everybody's ice cream.
So stand up a bit. I think we do again what we had this morning. Find a partner.
Sini lah, masuk.
Buka a bit lah, masuk a bit.
Oh, itu dah sana ni. Ni. Sana. Tik. Tik.
Turn the other side.
Tik. Sini pada Tik. Tik.
Everybody, buka a bit lah.
Jangan jalan.
Okay, what do you feel after the morning session about wellhead, whatever subtopics there? We did too dry, too mechanical,
Hungry.
too mechanical.
Too detail.
I think there are some questions about quiz and final exam and test now. But I wouldn't go too deep now on those questions. I think just some things. I think the way what I'm trying to make you understand on the pre-quiz, the quiz will be pretty much just to make sure you have the same understanding. Right? So it's not going to ask you to write a long essay. I think I couldn't write a long essay about wellhead also. Okay, then so we talk a lot just purely on the wellhead system, then the wellhead itself. So what we have as part of the function of the wellhead is to suspend the casing or tubing. So how it is suspend? You actually need this piece of equipment, hangers. Hangers is basically where we use to actually hang the casing of tubing. Imagine with the deeper wells that we are after now, one tubing string about 300-400. Some can be deeper when they are running big bore, 7-inch tubing. So this is a type of hangers we can have. Basically only two types. So one is actually manual type, the other one is sleek type. So sleek is pretty much, we emphasize quite a bit from morning. We talk about installation sequence. You can see the motion of cutting the casing. But when you guys are right, you guys I think raised quite a bit of question about barrier. Can we actually put down the risers, VOPs? What is actually the barrier to allow us to do that? So indeed, that's actually the huge concern now, especially when we talk about well control. So thereafter, I think that's why most of our systems are always coupled with a primary. And the primary one is always the manual hangers. So manual hangers is where allow us to actually pick up the last string of casing or tubing, then we make up. And the make up is using OCTG connections. So you make up and you have a running tool. Running tool to the casing hanger is a different track. Normally they call it a running track, which is active. So with that track, actually that allow us to run in, then we will back off the running tool back to the rig floor, and then we land this in the wellhead itself. So according to API 6A, there are 5 hangers. So indeed you can see we are not too much after the 1 and 2 now. We are typically talk about 3, 4, 5. At least we need a seals on the hangers. There might be old days people don't have the concern. The cement, they think cement is very good. They don't need the surface seals on the wellhead equipment itself. So those are those days. Now we install a wellhead with the hangers. We always want the seals to give us the integrity. So you can see it hangs apart, seals from two directions, hangs apart, and then this one with additional lockdown, retention, actually means a lock screw or the lock ring design, whatever, which have a retention onto the hangers itself to prevent outward movement. Because when you have a hangers, you have a seals. If you have a pressure from bottom, you will push it up. Okay, so that's how the retention features is. And then the last one, group 5 is typically on tubing hanger, where they have a PPV, which is a back pressure valve pop-up. That one is sometimes also we call tubing hanger plug. Okay, so that's pretty much like a mandrel hanger. So if you can see this is a mandrel hanger. I think in the modules you can see just right in there. On the left hand side is a primary. So primary come with this mandrel hanger. So what you do is this is running through lah. So what you do is really you pick up these hangers, then you make up to the last joint. Actual operation we normally have a pop joint because you need some handling. Because if you don't have pop joint, you are holding these hangers. And this hanger got no place for you to actually use a power tone to actually tone it. So what we do is normally we have a 5-foot pop, and that one is pre-make up on the workshop on the base where they have all this chuck machine, power tone machine, and that machine allow you to grab whichever video audio. But at the actual offshore, actual tubular running services, the power tone is typically just to grab the OD of that casing size. But if you can see OCTG, the whole string, they are all same OD on the OD connections based on the OD pipe, right? But hangers typically have some offset here, it's bigger. And you got no way to actually turn it. So practically, the operation you have a partner. So what happens is when you actually pick up this, your power tone is holding the partner. You are not holding this. So when you already make up to the last joint, then you pick up your running tool, and this typically is a left hand track. So left hand track, so when you turn left, you are making up. So when you're making up, you run from the reform, you run to the landing point, then you turn right. And why you want to turn right when you release right? Because turn right, you are making up. In fact, this is a reverse direction of your OCTG connection makeup. Those makeup is right here. So when you turn right to release, you don't back off your string, because this is heavy. Typically, it's not so easy to back off, but it's just a design theory perspective that people will prefer. That's come with the other direction. So this is basically left hand to make up. You guys can pass around the test it a little bit. So this is mandrel hanger. So mandrel hanger also got two types. One is a mandrel hanger with floated slot like this. So when you land, you can actually circulate through these hangers. You can tag returns. So when you circulate your cement, you tag return through the floor line. But they have another type, like the first page here. You can see they have seals here. So what happens is these hangers come with seals. So when you land this onto the wellhead, you don't have this foot slot. It's a solid with seals. So you have to tag the return through the SOV. So that's pretty much like here, if you can see. This one is also the slotted type. I think all this is slotted type. So you can tag the return through the flow line. But if this is blocked, this is plugged, have a seals here, you can only tag return through this SOV from the side. This one they didn't quite show the SOV this spot. Yeah. Okay, that's how the drill casing hangers are. Pass from here, sorry. This side. So that's how it is for mandrel hangers, landscape hangers. Then for mandrel hangers, the key thing specific running tool. So this running tool, there is no, API didn't tell you how to design a running tool. They did want you to design to certain capacity, but they didn't detect dimension, what size, what thread, and all this. So all this is really OEM driven. They can design all the whatever thread they like. So normally I say is an acme thread is because they have a reason, because it's high capacities, and also they cannot use premium thread connections because they cannot actually back off, because you need to release these two actually. So a specific running tool is required, and normally it's left hand. So if the casing cannot be run in this program, that means stuck. If I run these hangers to the rib floor, and then it's stuck in between, then we cannot land this anymore. Then that's why this is a primary, and it is always coupled with the contingency with the split hangers. So no floated casing hanger, then it integrates with seals. With that seals, then when you sit on that, you need to take the return through SOP. So floated mandrel hanger, floor bar area will make it up that is important. So so the advantage is for the whole things for this mandrel hanger is allow you to run through the BOP. You don't need the moment that you remove the BOP that you don't have sufficient barrier. So in well-controlled perspective, this mandrel hanger is definitely better. Especially when we talk about drilling into production casing and all this. They are at least equal in strength to the casing. So this thread is always designed stronger than the connections. So there is no slit, damage or deformation to the casing. There is no view cutting of the casing. You don't need to cut. Once you land this hanger, it sits on the wellhead itself. You don't need to cut it. So you see the slot, you can see the one is a square slot, but sometimes they come with a fluted hole. It's not even somewhere I didn't put the holes that symmetric. So this is where you take the return. So without the seals, that means you can take the returns through here. But non-floated is with seals, so this is all solid. So you can't take return through this type of hangers. So for example, of some data that you can see the casing hanger size in between which area, and then the return area that required. So what you don't want is you restrict your flow. So you have your head. So you have your hangers sit on. So if you don't have, it's a fluted type, so it's a true plug type. So when you cement, you pump through, you drop your plug, then whatever return you through here. So you don't want this port to be too small. So if it's too small, you will generate back pressure. And so it depends size. When we come to quite critical size, sometimes we do cementing simulation. Whether if we ask the wellhead provider is like 40 inch screw, we will use this to actually ask the cementer to do the simulations. But this is typically okay, I think, based on the data there. But always the worry is when the non-fluted type have a seals, wait, I need to tap through the SOV here, right? So this SOV is typically 2 inch and it's really small. So even two sides of SOV typically maybe is only about 5 inch square. So this is where the restriction that we always trigger cementing evaluation from their simulations. Okay? SOV is the outlet. Yeah, the outlet for the site. So if you can see the fluted hangers, right? So the fluted hangers doesn't come with seals, but it gives you best flow by that doesn't restrict the flow, doesn't restrict generate, cause induce the back pressure that you might actually induce losses to your downhole. So with that, then you are to install another piece of equipment where we call annular seals assembly or pack-off. So basically, it's a pack-off that create a seals. So this is really what our current system in the 3D model is. You can see all the hangers on top of that coupled with the pack-off. So the pack-off will come with seals. So this is the one that provides you the sealing capabilities. So we talk about running track. So the running track is what I highlight just now is typically OEM, right? But they call acme track, which is more common. So why we say that is because OCTG connection is typically a table track. You have a pipe body, right? Then you have some tables. Then you have pin connections. You call a pin connection. And then typically this box can be a coupling, right? So it's a table track. And this is where a lot of premium connection give you the metal-to-metal seals. They have some metal-to-metal seals on the news and all this profile to give you the seals. But this is not applicable for wellhead running too. Because when we make up this, we make up how anybody can throw any figure. How much we normally make up the connections. 20 keeps, 30 keeps, SFN, 21, maybe 20 keeps. As a power tone or tubular running that need to provide the amount of torque to that connection to give you the seals. But what we want here is only running the hangers to sit on the wellhead. And the key is I need to back off. If I back up 20 to 30 keys, either 2 pounds. So if we back up this one to 30K, the kind of high torque, we land the hangers, you can never back off this running tool anymore. So the thread for running tool on hangers is different to the OCTG connection. Because on OCTG connections, you don't expect to back off. Because when you back up, the whole string will be just there. And then just permanently stop. But for wellhead, you need to do. So wellhead, you have a running tool. Let's say this is the hangers. And then they normally have this thread. And you have a running tool coming from this thread. And this thread is typically acme. They call a straight thread. Acme. Straight thread. What straight thread means is actually this. This straight thread, they have some profile, some different angles and all. So if this is a near thread side, this is a medium thread side. So this near thread coming and engage here. And this kind of acme thread is straight thread. It is high capacity. You can pick up the load of millions pounds, but it's not giving you the seals. Because if you can see, this is really straight. There is no table, no sealing metal-to-metal profile. So what they do is normally they will put just O-ring or whatever elastomer seals in it. So wellhead running tool always associate with the need of the elastomer seals there. So the elastomer seal is not shown here. I think this one is what I asked Solar Help to provide to give you the feel how the motion, the right hand and left hand turning, but they didn't put the seals there. For this running to is really just chanting. So what they do is really just by the label, of course certain top value, but it's just like few hundred. It's definitely not the seals, not the high top that require you to actually generate the pattern analysis on any previous conditions. And if you overturn, you talk it a little bit, actually it's difficult. So we normally say just hand type. We never say talk on this kind of running thing. If you look at procedures, right? That's why you calculate, you just count on both things. So this track engagement, let's say 10 turns, you just calculate 10 turns. And the last turn, you normally be careful. Because if you lose your grip, you just go ahead. When you talk, you can try lah. This one, I think, just now also I power, I lose a little bit power, right? Then it's a bit difficult to actually back off. But imagine that's what we want. We landed on hangers. I probably, at this landing point to the rig floor, I probably have 50 to 70 feet. And you are having a landing rod joint at that length. And you just never able to break it off. And that kind of difficult to break off entities does happen from the past. Okay, so manual hangers, if floated, then you need a back off, you need to set a back off separately. So this is also this is actually the back off. So if you can see, this profile is supposed to have a skew. So if you can see, this is the lock ring type. So this is the lock ring type. So what you do is, it's also the left hand track. Back up, then you collapse. So what you do is you collapse until the lock ring is flush. It's flush, then only you can run through the riser a little bit. Then you turn the other way. When you reach landed, then you turn the other way. You pops up, then you lock to the right. So this is actually a pack off come with lock ring. So slip hangers we talk about, we need to cut. This video is quite good. I think it's really show a man right elevation trying to do this. So this video is not really in English, it's in Arabic. But I feel this is one of the best. So you can see this is really the casing in place, right? But this one is sure they didn't, it might be riserless or they already removed the BOP and risers. So what you can see is really the wellhead there. So you can see the mud they use, right, is really dirty. You need to flush, clean everything. 17 minutes plus, I don't think, I think I will fast forward a little bit to the one. So this is the stick. I feel difficult to explain the motion of dropping the sticks, but this is practically the scene. This is the stick hangers. Sorry? Anyone, you ask me?
Slip kan macam klip je. Makin kita tarik bawah, makin dia katuk. Makin dia ketat.
Pull out.
Kita nak tarik bawah. Kita set casing kau dalam position tu.
This will be a
So dia ni actually dia akan
the
pull
cap
down.
screw have to remove.
Makin dia pull down makin ketat.
The cap screw is to retain the slips. I think you can see they have the slips here, right? Slip here, you don't actually, you normally have that screw to retain it. But when you drop, you remove the cap screw. Because the cap screw is actually the protruded part. So you must remove, then only you can drop it. Let's see. Okay. So what happened is it's actually like a C or two half. So they have a head, they have a hinge here. So this hinge is the lock, the opening. That's why normally they all wrap around. Now they just clean a little bit, make a long one. So the casing is in place, but no hanger there. You just clean the put on. So this is what they call put the two wooden board on top of the head.
Berikan casing pada pecah tu bawah.
Emergency is if we have primary, we call emergency, which probably is the casing starts. Here we need to set the sleep hanger. So sleep hanger sometimes go as an emergency. See now they open, the red will not go. Actually, red will open. So when you go around, you can let it back.
Buat jadi pun tak muat dulu.
Dia dah ketat baru kau potong.
Dia ke bawah dah
Kena biar lah.
biar pun jatuh. Berat tu tarik dulu.
Can drift through the.
Ini sekarang dekat bawah tu tinggal letak yang slip. Dia terangkat.
Dia ada slip kat atas.
Oh tak, dia kat bawah.
Once they remove, then there is no retaining on the slits.
Apa?
So the slit
Pakai lengki juga.
actually find its place around the casing.
Allah.
Ayo kita lepas buat sini cuba dia bersiapkan ini juga.
Dah.
Baru dah
Kamu sudah. Pernah.
Baru pasang ke ini. Ini apa?
Yeah, just a so all the slip hanger normally defaultly they will attach with the key like here. It depends. So they put some grease. You see they remove the cap screw, so it's flush. The OD have flush. You see, they just wet. It is difficult.
Macam mana si dia wood
Ni apa je?
So they put grease on it.
Maksudnya dia macam tu je. Tapi dia letak
Ini apa?